technology. I think he liked graph databases, and he just claimed, well, it's a shame that there are no those many use cases where you can apply graph databases. I said, no. That's completely wrong. I mean, I think there are many applications for graph databases, and I think David will help us understand that today. We are very, very happy to have David here. So far in the last kind of 12 months, there's been a few people from Neo Technology coming here, Michael Hanger, Jim Weber, and now David. David flew from Stockholm in Sweden, so I leave you with him now. Thank you very much, and welcome, David Montag.
All right, hello. Is this thing on? It's okay? Perfect. Hola, yo no hablo español. Me llamo David. And this is my colleague, Bill. And his business card is here. If you're interested in staying in touch with us, Bill is based in Spain, so we have a presence here. And I would like to introduce you to Neo4j and graph databases today. So let's get one thing clear first. These are not graphs, right? These are charts. This is a graph. Graphs consist of nodes that are connected by relationships, right? And this is not a new concept. It's actually been around for a really long time, about 300 years. And it all started with Leonard Euler, who was a mathematician back in the day. He lived in a city called Königsberg. Does anyone know what Königsberg is called today? It's called Kaliningrad today. But anyway, back in that day, this city had 7 bridges, and the city was split into 4 regions of land by this river, Pregel. And there was this kind of urban myth, this common problem of, can you start in one place and then walk around and cross every bridge exactly once and then get back to where you started? That was the big question, right? And nobody was able to really prove whether it was possible. Nobody had succeeded, but that doesn't mean it's not possible to do, right? So along came Euler, and he thought about this for a while and realized that it doesn't actually matter what streets you take over here. So he abstracted this city to just these 4 regions and these connections. And when he drew it on paper, it's what he labeled a graph, right? Nodes connected by relationships. And in the end, he was able to prove mathematically that it's not possible to do this walk in this city. You have to actually change, maybe destroy a bridge or build another bridge or something like that. But at that time, it was not possible, right? So a lot has happened since the 1700s. Now we're in the 2000s instead. So let me show you a picture from Facebook. They took about 10% of their data and visualized it. And what they drew was cities and relationships between these cities. And the line is thicker, stronger, if more people know each other in these cities, right? And they plotted this data on a completely blank canvas. And from this data emerges, well, a map of the world, right? You can see continents, you can see borders, cities, and this is just from data of how people know each other and what city they live in, right? I think this is an interesting story of how you can learn something new from data that you already have. And that's what graphs are really all about, right? So how does this then relate to your actual business? Well, in your business, you may deal with things like customers, right? You may deal with products, sales, and many other kinds of data. This data is often kept separate in silos. Different kinds of systems know about different parts of the business, right? But if you think about it, beyond your customers, your products, your purchases, you may have things like product categories, stores, regions, and much more, right? And it turns out these things are all related, directly or indirectly through each other, right? So by using a graph database like Neo4j that focuses on the data relationships, you can uncover patterns and trends that are just not visible in traditional systems, right? By looking at the data in a different way. And costly investments are often made into infrastructure that just fundamentally is not made for this kind of data. Right? This is a pretty simple schema, right? It's the Drupal schema, by the way, for CMS. Neo4j is thousands of times faster than traditional databases. And that's really the differentiating feature. So you need to forget trying to tweak your relational databases to work with your modern use cases. You actually need to pick a tool that works for the right problem, right? The right tool for the right job. That's what it's all about. So where is Neo used today? Well, let me give you some examples. One of the largest countries in Europe uses Neo to route all mail in that country. So whenever you mail a package, it gets scanned, and a calculation runs in Neo. How do we send this from point A to point B, based on how the graph looks dynamically at that time, right? So if you cancel it, it will just return in transit back. It's not even going to reach the other destination, right? Whenever you buy an item in a Walmart store, that purchase is analyzed with Neo to understand what kind of things do you like to buy and what other kinds of products can we recommend to you, right? It's all connected. When SFR plans their network, they use Neo4j to understand what's the impact of this change, right? If we change the network in this way, how's that going to impact something at the other side of the country? They own more than half of the fiber in all of France, right? It's a big company. When a piece of network equipment breaks, HP uses Neo to find out how does that impact the network in the bigger picture, right? And what things are connected to this thing and who should we notify, right? Who should we alert? When a client or a trader signs on with UBS online portal, right? They use Neo to present the right assets to that person at that time based on what they need, right? If you have a trader that's sitting unproductive, that costs a lot of money for a large investment bank. If you order an item online with eBay Now, which is not available in all cities, but if you live in a city where it's available, you can basically order any retail item to your doorstep in like 30 minutes, right? Which is really cool. It's faster than a pizza for like a TV. And all scheduling of all deliveries of that runs in Neo to figure out who should deliver it, when, to where, from where. Whenever you go online, if you have a support case with Cisco, they use Neo to figure out what other cases are similar to this case and what kind of solutions can we recommend to you. Maybe so you don't even have to pick up the phone and call the help desk, right? It's also connected. Whenever TomTom modifies a map, so they add a new road or remove a road, they use Neo to figure out, well, does this actually create an island in this graph, in this road network, or is it still coherent? Is it still correct, right? And Lufthansa Systems uses Neo, so whenever they put a new movie onto an airplane, that's tracked onto every hard drive and so on, every bundle, it goes onto every plane. So when they need to revoke that movie, they know exactly where it is in the most efficient way, right? These are just some examples, a small handful of our customers, but hopefully that gives you some idea of where graphs are applied. Hint, it's pretty much everywhere, but, but you need to conceptualize it in your business, right? So we work with analysts as well. Forrester, which is a large analyst institute in the US, they think that in 2 years, over a quarter of all businesses will be using graphs to solve these kinds of problems. And today, it's about an order of magnitude less. Today, it's between 2.5% and 5% of all businesses that use graph databases in some way. So it's really increasing right now. And Gartner thinks it's the single most competitive differentiator for businesses that pursue data-driven operations. And all businesses today are trying to do data-driven operations. You need to have solid data to make solid decisions. So you might think that this is new technology. It's actually not new. We've actually been around for 15 years doing this. And it all started in 2000 when we invented the model. A few years later, the product was put into production, has been in production since then, internally at another company. In 2007, it was spun off as its own company, And since then, we have sold this product and developed this product ourselves and brought it to market with these customers. And today, we're quite large. We have over 1 million downloads of our product, and last year we did over 500 events. You could be talking at a conference or organizing a conference. It's more than one per day. So we're working hard on getting the message out. We have a lot of customers, but we're kind of a dark horse in the market right now. You may not know that a lot of your services are powered by graphs in the back end, right? So let me just show you the product so you can conceptualize it a little more. It's very abstract right now. So let me show you. If you just download it and fire up the developer interface on your machine, this is what it looks like. You can see a little terminal up here, a little console. This is where we type our queries. If this were an SQL database, it would be SQL queries, but it's not an SQL database. It's a graph database. And we type Cypher here, which is our own query language that we use for graphs. So remember, the whole product is built ground up for graphs. So let me just show you one data set here. I'm just going to run a create statement here. This is like an insert in SQL. Run that, we'll see what we get back, and we'll take a look at this. So this is what the data looks like in the database when we look at our result. This is what we do at Neo all day long. We just play with balls. You know. Just like everyone else, yes. Exactly. But it's fun, right? So what can you do with this, right? We have a simple supply chain example here where we have a customer who owns a car that had a service event used a service package, including a couple parts from a supplier, right? Quite a simple data model. This is the actual data. Now, what can we build with this? Well, we can say, for example, for a given customer, what suppliers did this customer get parts from, right? That would be a kind of complex query in an SQL database. It would probably be 8 or so joins to get to the other side, and it would take quite a long time to answer that question. In Neo, we answer it in milliseconds, and it's a few lines of Cypher that are very readable. Right? It's a very big difference. And you can turn it around, and you can say, for a given supplier, which of all customers got parts from me, but maybe only the ones where a certain dealer installed the package, right? It's a different pattern you can look for. It's all about looking for patterns in the graph. We also do something that no other database can do, which is what we call discovery. If you pick 2 nodes, let's say this dealer and this user, we can tell you how they're related, not only directly, but also indirectly through the graph, right? Because the database is fundamentally aware of these relationships, and it can walk them for you, right? An SQL database is not going to auto-join anything for you. You need to know exactly what you join on every step of the way, and it will not tell you anything that you don't already know, right? In Neo, you can find out how's this thing related to this thing through the graph. We will tell you that, and we do it like that, right? For example, in the logistics use case. That's a very brief introduction to what we do with Neo. I'm not going to show you any queries right now, but happy to show you after the presentation if anyone's interested. So, in the past decades, we've seen an immense growth in data volume and data connectedness, right? And this is something that traditional products were just not built for, right? We've seen a lot of new products come to market lately, and they address this kind of problem. However, the kind of growth we've been dealing with is exponential growth, where things double over time, right? And this is hard to conceptualize. It's hard for us to understand what is exponential growth. So one example is if you take a piece of paper and you fold it, we can all fold an A4 piece of paper about 7 times, right? And then it's too thick to fold. And at that point, it's about 1 centimeter thick, right? If you fold it another 7 times, it's about as thick or tall as I am, right? Fold it another 7 times, and it's about 200 meters. Another 7, and it's twice as tall as Mount Everest, right? Fold it 42 times, and it reaches to the moon, right? This is the kind of growth we're dealing with in data right now. And substitute foldings with years, and that's what we're looking at. Now, it's reasonable to think that technology that was built for this kind of data is not the only technology we need to deal with that kind of data, right? We need to augment what we have with other kinds of products. But a lot of products today have focused only on volume. And there's actually another dimension to data, which is connectedness. How does it all relate to each other, right? And a lot of products focus on this, and they forget that part. However, connectedness is becoming more and more important. It wasn't as important before because we weren't dealing with so much data, but now we are. So let's take one example within, let's say, invoicing, right? If you go back 15 years, an invoicing application may only have cared about basically getting the right amount into the accounting system, and that was it, right? You're done. But if that's the only thing you're doing with invoicing data today, you're missing out. Because this invoice is, of course, related to a person that has interests. This person is in a social sphere with other people that may be influencers, right? If you're not targeting these people, you're missing out on information. And the invoice also has products that were purchased, right? These products are in categories likely. What are other products we can recommend that go well with this set of products based on what other people bought, right? Which product can we substitute for a more expensive one? If you're not looking for this data, then your competition likely is, right? It's all a race, and you have to stay ahead. You have to look at these connections to get more from the data you already have. And when you look at solving this, you kind of end up at a crossroads where you can choose to either denormalize your data, which means you basically aggregate a lot of data into simple documents. So if you take, for example, a product, in that product, you also put in all the information about the categories it's in and other kind of info, right? The other way is a richer model where you don't inline all the category information into the product. The product is its own node. It is in a category that may be in a parent category, that may be in a parent category, and so on. And if you look at that richer model, that opens the door for different kinds of questions on that data that you may not have thought of before, that are not answerable with a simpler denormalized model. The denormalized model is made for answering one question. If you want to answer something else, build a new model, build another denormalized model. So you end up at this crossroads, and comparing the NoSQL databases that are out there today, you see a lot of products that have gone in the denormalization direction, right? Very simple data models. Essentially, they're all key value. And you need to basically compute your answer, put it in there, and then you can ask for it out. We've gone in a different direction where we want to normalize your model as much as possible and allow you to ask rich questions of your data and really ask anything of your data, right? That's a fundamental difference. And it turns out this matters because if you look at growth in database categories over time, graph databases and Neo4j are by far above all other kinds of databases today, right? We're growing with over 500% per month right now in terms of popularity. This is from an independent site that ranks all databases, right? And one reason, as I mentioned, is the performance of graph databases, where we do things thousands of times faster. What used to take minutes or hours can be had in the time it takes to click a button, right? That's a very big difference, and it changes the way a business can operate. But there's also the graph modeling aspect, which is often overlooked, but when you start looking into it, it's one of the most powerful aspects. Because when we're working with any kind of data, we often go to a whiteboard to draw it, right? We want to figure out, okay, we have a person here, they work at this company, this person bought a product, yada, yada. If you work with a relational database, you're not done then, right? You need to go and make your schema from that. If you work with a graph database, you're done, right? Whatever you drew on the whiteboard is exactly what we will store in the database. And a couple days ago, actually, in Stockholm, I was talking to the CTO and a senior advisor of a 15,000 person company. And they're doing a pilot with Neo4j. And when we talked about this aspect, that was one of the things they actually liked the most, which is that they and other business users can actually speak the language of the developers, right? They can point and say, I want this thing to be related to that thing, right? And that can be implemented exactly that way. There is no talk about tables, join tables. There is no translation that needs to happen. What's in the database is exactly the business language that you use. It's very powerful. So what is this used for? You've seen a couple use cases. I'll just give you a couple more. Real-time recommendations, any kind of recommendation, right? It could be an insurance person, an insurance salesperson who needs to put together the best package for a customer, right? They can get recommendations on what kind of products should we recommend to this person based on what we know about them, and so on, based on what we know about those things. Fraud prevention and detection is another strong use case. Unfortunately, it's not one we can talk a whole lot about because there's a lot of confidentiality around it. But as you might imagine, if you can figure out how one thing relates to another, which relates to another very, very quickly, you can do a lot of interesting analysis on transactional data. Master data management often comes down to taking a lot of different data sources within a business and putting it together to get a bigger picture of your business. It could be data about, well, your customers, right, your products, your sales. You put that together, you can suddenly ask questions, make reports, and so on that you just can't do very feasibly, at least, with traditional solutions. Yes, you can pay a bundle of money for SaaS to do that and train a bunch of people, but you can do it much easier with Neo. Network and IT, I mentioned a little bit before, also very strong use case. It's very graphy. Identity and access management, also figuring out this user is in a group that's in a different group that has access to a folder that contains a folder that contains a file. Is this user allowed to access this file? Well, it's kind of complex. So you can pre-compute all that, fine, but when things start moving around up here, you need to be able to do that in real time. Otherwise, you're going to struggle. Graph-based search. Actually, Facebook, I think, trademarked the term graph search, so we're going with graph-based search instead, hoping that sticks instead. But it's basically any kind of search where, and we're seeing that increasingly, where you just want to take your data and put it in Neo, and you want to ask graph-based questions on it. You don't want to ask aggregate-based questions like find me all customers with this age segment or so on. You want to figure out more around the data relationships. How do things fit together? The big picture, right? Lastly, this is a segment of our customers. Like I said, not all are here. We can't, there's a number, especially within finance, that we can't talk about right now. But we really see graph adoption across the board. And we think that's a great sign. We are seeing adoption picking up really by the day as far as onboarding customers goes. And it's great to see businesses really doing more with their data and not just letting their relationships rot in old databases. All right, closing remarks. We are having a conference in London. This is our biggest conference in Europe for this year. Looking forward to seeing some of you people there. In San Francisco, last year we had 700 attendees at our conference, customers and other people who were interested in learning more. So we would love to see you here. I believe we have a few tickets we can arrange for. If you're willing to travel to London, we can sneak you in the door. So we can take care of that. So we're looking forward to seeing you there. Have customers like Adidas, Pitney Bowes, Orange, and others speaking, so that should be good. And hopefully you can consider yourselves introduced to graphs now. And this was the last session, so yay, nobody fell asleep. Thanks. questions? Yes?
Thank you. Thanks. So thank you. Yeah. I've been recently using Neo4j, and I'm quite impressed with how it works. But I'm concerned about how it's going to scale, because I've read about that, but not really like real numbers. It's like, yeah, it can scale to millions, but millions is not a number. It's just a plural. So I would like to know, I know it really depends how much data you put in your nodes, but suppose you put like really small things like IDs and a few tags, and that's about it. And how it will scale to not millions, but several millions? And can I distribute the system? Because last time I heard about Neo a couple of months ago in a conference, it was like, we are working on distributing, Neo in different nodes, but I'm not sure if it's like, ready for cluster or something like that. So if you have any information.
Yeah, absolutely, and that's a great question. So, I mean, some of our bigger customers run with billions of nodes and up to 10 plus billions of relationships. So you definitely don't need to get into any kind of partitioning of data. This is something that if you go the denormalized route of data, then partitioning is easy, right? Because you're just writing a value and reading that same value back. That's all you're doing. But if you're dealing with relationships and you want to walk this graph quickly, you actually don't want to partition it as far as you can avoid that. And today, on a single machine, we easily run with billions of nodes. So
that's quite impressive. Thank you.
Yeah.
Somebody else? Very good. So, David, it's been a pleasure. Thank you very much. Very interesting. And thank you also, everybody who joined us.
And thank you, Ruben. Fantastic.